It is another beautiful and lovely day. Welcome to Mathematics Meal. Today on Mathematics Meal, we have a pizza that we are going to enjoy together. Join me as we enjoy this pizza. Subscribe to our YouTube channel at Mathematics Meal 1. Follow us on Facebook at Engineer Aiko Kechku, and also follow us at Mathematics and Science Meal on Facebook. Alright, let's begin the journey together. You are going to love this particular mathematics pizza, so let's enjoy it together. Okay, we have this log, open bracket, log 125 in base 5 plus log 81 in base 3 plus log 49 in base 7, all raised to power 1 over log 64 in base 8. Now, looking at this question, we have log 125 in base 5 plus log 81 in base 3 plus log 49 in base 7, all raised to power 1 over log 64 in base 8. Now we would have used the first law of logarithm to combine all this under a common log, but they don't have the same word, they don't have the same base. Because that first law, which is log m in base, let's say base b, plus log n in base b is something as log m times n in base b. So this can only be applied if the two logarithms are of the same base. But in this case, this is base 5, base 3, and base 7. So what are we going to do? We are going to handle this individually using the method of simplifying expressions or terms containing single logarithm. So we are going to simplify this using, in our previous video, there is a method we call ancestors method. If you watch our video on logarithm, you are going to see that method. So we are going to simplify this. So because of space, we can write this. Let's continue here. We can say that this implies, now 125 can be written in powers of 5 because 5 is the ancestor of 125. So I can write this as 5 raised to power 3 in base 5 plus log 81 can be written in powers of 8. So 81 is something as 3 raised to power 4 in base 3 plus 49 can be written in powers of 7 because 7 is the ancestor of 49. So 49 is 7 raised to power 2. Then 1 all upon. Now 64 can be written in powers of 8 because 8 is the ancestor of 64. So we can write this as log 8 raised to power 2 in base 8. Okay? Now we know that the power of a number in a logarithm is the same thing as the coefficient of that log. So we can write this as 3 log 5 in base 5. That's the third law of what? Logarithm. The power of the number is the same thing as the number multiplied. That's that power multiplying the logarithm. So plus, this is something as 4 log what? 3 in base 3 plus 2 log 7 in base 7 raised to power 1 all upon 2 log 8 in base 8. Applying that same third law here. Now we know that the logarithm of a number to its own base is 1. So log 5 in base 5 will be 1. So this will reduce to 3 times the whole of this is 1 because log 5 in base 5 is 1 plus 4 times log 3 in base 3 is also 1 plus 2 times log 7 in base 7 is 1, all raised to power log 8 in base 8 is 1. So I'm left with 1 over 2. Yeah, because the whole of this is 1. That's 2 times 1 will still give me 2. So we move further. 3 times 1 is 3, 4 times 1 is 4, 2 times 1 is what? Is 2. So we're going to have 3 plus 4 plus what? 2, all raised to power 1 over 2. That will give us 9. This plus this plus this is 9 raised to power 1 over 2. And that implies 9 raised to the power 2, 1 over 2 is same thing as square root of 9. And that will give me what? 3 as my answer. So the whole of this will reduce to 3. So we can say this will give us plus or minus 3 because square root of a number is plus or minus a certain number. Yeah. So that's just the simple way of enjoying this particular pizza. Yeah, we can look at it again and again. But for you, if you want to really understand the concept of what logarithm, just go to our YouTube channel or go to our Facebook page, watch the videos on what? On logarithm. Then you will understand the basics of theory of logarithm. Thank you for enjoying this pizza with me today. Let me tell you, more pizzas are coming. I love you.